discuss about the supervised learning and deeper concepts like overview of supervised learning, like a definition we called learning with labeled data, and the goal to predict outcomes for new data, and the common algorithms you can use linear regression and HVM support vector machines and decision tree. The key concepts of like features and labels, and after training and testing split and model evaluation metrics. And we go into linear regression and deep dive. Assumption of linear regression, the like cost function we call it we mean squared error. The optimization are called gradient descent. For the optimization, the logistic regression we use for classification problems like sigmoid function and cross interval loss. And another thing is the decision trees. Like a tree-based model and switch to data based on feature values and prone to overfitting without pruning. Decision trees and tree-based model and switch to data based on feature values prone to overfitting without pruning. And also support vector machines SVM find the hyperplane with the maximum margin, effect in high dimension spaces, kernel trick for nonlinear classification. Um, what we do SVM like find the hyperplane with maximum margins and effective in high dimension spaces, and the kernel trick for nonlinear classification, and k nearest neighbors, k in how like instance based learning, and no explicit training phase, and sensitive to choice of k and distance metric. The model evaluation or accuracy and precision recall like F1 score and confusion matrix and ROC curve and AUC. They are the things the model evaluate accuracy, precision and recall, F1 score, confusion matrix and ROC curve and AUC. Under cross validation we can use k-fold crash validation and reducing overfitting and ensure robustness of the model. The class validation techniques use k-fold cross validation to reduce overfitting, ensures robustness of the model, and bivariance trade-off like we use bias error due to incorrect assumptions and variance error due to model complexity. The goal is find a balance. Overfitting is underfitting or like overfitting is a too complex model and underfitting is a too simple model. Use regularization and cross validation. Regularization techniques are L1 regularization lasso, L2 regularization reach, and helps prevent overfitting. These are the techniques we use. Regularization techniques and hyperparameters like tuning, grid search, random search. Use validation set or cross validation improves model performance. At the summary and application is a recap of supervised learning algorithms, use cases or snap detection, fraud detection, and medical diagnosis. These are things. Thank you.